So hello everyone, as I've already said, I wanted to start off today's session with giving you a little background on who I am and what Tweddle is. You already heard my background from the presenter. And Tweddle is a company that really defines itself by identifying customers' challenges and providing a solution. Now, we're not exclusively a transportation company, support company, but definitely that's been our area of expertise, and that includes agricultural, capital equipment, and vehicle diagnostics and support. But you can tell that in that channel, not every customer has quite unique challenges. They're all fairly similar. So we'll define a solution, bring it to a customer, and then see where else it can be applied. And if you don't change with those opportunities, things will find themselves. So Tweddle right now has about 500 people globally. It's been interesting for me as a diagnostic professional to see and get feedback how COVID-19 and the world is adapting regionally. The differences are quite stark in how either a culture or a market adapted to remote diagnostic years ago and is just expanding it, or a market that traditionally has not engaged in remote diagnostics is doing things differently today. We'll talk more about that. The focus for the Tweddle group is really in the life cycle management and service readiness activities for OEM manufacturers. This includes working with upstream engineering support of companies all the way through the management of that change that has to happen with a product life cycle, and then the delivery of the content. Interesting to note that the delivery is not just to the end consumer of the product. It can be to upstream engineering, it can be to a warranty analyst. Depending on the product, multiple deliveries are definitely a possibility and the rule, not the exception. From a customer perspective, here's a quick splash. It's a partial list of the customers we've worked with various offerings. Owner information, definitely still a focus for our business. As vehicles get more complex, being able to explain how to interact with the different systems, especially with ADAS coming online in the last few years. It used to be the garage door opener, home link, and setting the clock were the single biggest things used. Not so true in today's environment. From a service diagnostic perspective, the wiring diagram seems to still be the most used diagnostic tool for technicians, at least here in North America, but that format's changing as remote diagnostics come online to support the added personnel. We're experiencing quite a shortage of technicians in North America, so bringing entry-level people on with the support of call centers and tools like remote diagnostics, again, is becoming the rule, not the exception. I'd point out that vehicle relationship management is a rather new offering, and it's been brought online in the last few years by the connected vehicle itself. So having a way to interact with a vehicle remotely, gather data, and then provide an update. It's a company that's doing a good job today of over-the-air updates without a customer even really being aware. You just get a notification on your screen the next time you come in that, is there an update available? Yes, you'd like to process it. They get your okay and then move forward. But let's jump into our topic for today. I think I've given you reasons why I'm here today to give an opinion on this topic based on the experience. The challenge that we have right now, and this isn't a North America thing, you know, the 3 C's of complaint, cause, correction continue to be a standard across the world, no matter how it's called out. And the measurable of fixing a vehicle at the first visit, no matter how the manufacturer calls it out, which acronym they use, definitely still remains a credible and reliable measurement of success. Did you understand the customer's complaint, and were you able to address it in their first visit, so there's no perception of coming back for the same repair? And today, I'd say at least over 50% of the warranty costs in a product are related to electrical, the complexity in the multiple CAN buses and infrastructures. It's not getting less complex, it's absolutely getting more. The amount of field service actions, recalls, and in North America at least, NHTSA mandated changes are definitely in that electronic area. And the good news for the OEM manufacturers, in many cases, they can adjust some firmware, some software, or an update without adding any parts. And for those manufacturers who are connected, they can even avoid the labor of a technician having to install that update. They can do it remotely, as I mentioned, Tesla has done for a few years now. ECU, the late 70s, early 80s, definitely ECUs had their problems. You could hit a bump and a vehicle would stall and not perform as expected. The hardware is much better now, but the firmware and software can be adjusted because manufacturers cannot anticipate all real-world occurrences in their life cycle planning. Technicians, from a challenge right now, that vehicles are more complex, things are changing, and it's important for them to get feedback on how to repair an engineered problem. It's very difficult for a technician today to address a problem if it's embedded in the software. Replacing a component will not fix that type of problem. So getting feedback from the field, getting a technical service bulletin out, or the availability of a software fix is paramount importance for a technician to have the proper repair available to him in order to fix this vehicle. And where does that knowledge come from? So right now, technicians see more of the real life issues attacking vehicles today than the engineering community, who spend all their time prepping for launch. They put their vehicle out, and this graph attempts to show the knowledge gap that starts to grow. So engineering knows exactly what they built and how they expect it to react in the market, in the real world conditions. They've done cold weather testing, hot weather testing. They've done a lot to try to understand how it's going to react. The technicians see the real world, not the anticipated world. This slide attempts to show you the normal slow feedback process, and I won't go through every step for time, but if you started the service bay with the vehicle in the kind of the middle on the right and follow it through, this is a typical current state. And it definitely is a challenge to get knowledge from the field to engineering, a fix identified, and back out to the field without hundreds, if not thousands of vehicles and consumers going through the system before that update is available to them. And that's one of the issues that remote diagnostics can help speed up. So the smart solution that we're working on with Empolis, so think of Tweddle as the front end, Empolis is the knowledge base or the engine that helps drive the process and makes distance diagnostics and remote vehicle diagnostics available. That cloud in the middle is the glue that holds it all together, and we gather vehicle information, apply it in the cloud with the tools that we have, and then provide an analyst with a workbench, a technical hotline offer can connect with a technician in real time through the application, working on the tools to fix the vehicle in real time. And technical writers can get the detail they need to provide an update. So at the end of a diagnostic case, the value that we bring is identifying the root cause and providing that session history. Again, that's where a call center agent can look at the steps that were taken, an engineer can analyze it, an analyst can look at it, and they're available to quickly define and identify a trend. The components of the solution, so knowledge base, you heard me mention that earlier, the power of the Empolis knowledge base and engine in conjunction with the front end and algorithms that Tweddle provides really creates a powerful tool that can be done automatic, connected to a vehicle, or can be selected by a technician. It can be DTC driven or it can be symptom based driven. And I'll show you that in my case study here in a moment. Features and benefits, I've spoken on most of these already, but the quick one I would point out is the fast feedback from the field and providing a force multiplier to allow an entry-level technician to have the delivery, which is speed and accuracy of a seasoned veteran. Enabling that person who may not have all the technical expertise to act as such is really an important part of the deliverable today, making technicians more effective. So from a Tweddle perspective, these are some sample screens. What I'd point out is multi-code diagnostics. Definitely one of the challenges for an entry-level technician. You've plugged your scan tool in, you're looking at something and you find there's 11 DTCs. Where do I start? Remote diagnostic systems, such as integrated or intelligent diagnostics, helps organize the attack and the approach of a technician. Then the solution relevancy algorithms we have definitely help him identify the rank solution. This is more probable than that. So they're not a parts changer and guessing. They're getting, where do I start? Where do I end? From a support perspective. For the technician, again, it's important not just to make this a mandated click the button process. It has to be a value add, and being able to walk someone through, but also provide them more information on how the system operates. To me, this is training on demand. A seasoned veteran can quickly click through and get to the correct answer, supported by the system, or a novice technician can take a little more time and, where needed, pull up the schematics, get the system overview, get the theory of operation, and understand how the system works, because fixing them today, this vehicle today, only helps on that one vehicle. Understanding the process and how the system works helps every other repair that that technician will take on. From an OEM, the analytics, I'll say here in North America, the TRED Act made vehicle data collection a requirement, but it brought on analysis paralysis in many cases. There was so much data. The analytic tools here in a dedicated diagnostic system clarify and bring the trends to the surface, which is very important to be able to have a fast feedback change plan. So we're going to jump into our solution overview here on a case study for the Dues Bobcat team. And it's really, again, driven by the Empolis Tweddle group collaboration on a solution that takes the back-end support of Empolis and the front end of Tweddle, along with the algorithms that make adaptive learning capable. So we'll jump right into our case study. So an interesting thing for the Dues Bobcat integration that I've chosen to show you today is it works in a couple of different ways. If you're connected to a vehicle that has a cloud connection, it simplifies everything in remote diagnostics. I know the vehicle, I know the build configuration, I know what DTCs are present, and basically all that's required to start is the technician to say, I'd like to start this diagnostic. It's equally easy in a manual session, but there's a couple extra steps. They just have to identify what the vehicle is and what the DTCs are, because the system hasn't been pre-populated with those. From the next perspective, it's important to note that not every problem with a vehicle is DTC driven. The example we're shown is such, but there also is the ability to do a symptom-based diagnostic. So if it's a vibration, noise, and harshness issue or some other symptom, we behind the scenes have mapped it to the proper DTCs, hesitating, stalling, those types of things, symptoms of a product, even though a code has not set. So a technician can either select a symptom or type in the prevailing, existing, or memory DTC. From there, guided diagnostics is fairly simple. It's if you're connected on a cloud vehicle, you have the ability to pre-answer questions, because the system can look in and see what's the battery voltage on pin 1210 of connector 472 without having to ask a technician to check it. So being linked to the vehicle definitely has its advantages, but it's not a requirement of this system as well, as long as the system questions are answered correctly. So on the right-hand pane, you'll notice the components and possible causes are at the bottom. They're ranked just in a visual way of what the most logical based on the questions. And if there are 7 questions in this node of a tree, you'll see that it narrows down from possible causes as we rule out or eliminate potentials every time more information is provided. The lower left of the screen is additional information. So again, this is that training on demand. We've shown where a technician that's experienced can click through and answer 7 questions, take a voltage reading, provide it, and get an answer that he's confident is the correct one. A more novice technician who wants a little more support, but also wants to understand how does the system work, or where do I take that measurement from? All of that is available in the solution, but it's selectable. We feel by having this type of technician the fastest path to the correct answer, but also walking someone who wants a little more support through the correct process as well. So again, he's answered a question. We're asking for the next voltage reading for this fuel temperature. The picture on the left is something that's available in the application to show where he can take a reading from to move on to his next step. And you'll notice the potential causes have slimmed down and the ranking has gotten higher. At any time, a technician can go back and look at his previous steps to evaluate how he answered the previous question as he goes through the diagnostics. You'll see his history is in the lower right-hand corner as well. So when you get to a solution, so based on the answers and or measurements, readings taken, we're walking a technician through the correct diagnostic, engineering approved approach. We get to here's the selected solution. It doesn't end there. We want to know, did things work out properly? So when the technician performs his component, we can show him how to install and or calibrate that component as needed. So diagnostics is only one step of it. The replacement is another, and many times for a module, for example, there's a flash procedure that's needed. All of that is connected here, so you get a full round trip from the complaint, the cause, and correction. And at the very end of it, we're able to collect details on that session. We want feedback from the technician, and we're using this to provide warranty information. Some of our integrations go so far as to get warranty prior approval on components. So we've shown through the diagnostic test history that we've done the test the proper way and we've condemned the proper part. We're not pulling a shotgun and just guessing at what the problem is. So now you could almost have the automated warranty prior approval because you've captured the data on the VIN, the vehicle, the component, and the test was done requirements. So another interesting point from a test study. So we have taken experienced technicians and novice technicians, put them together and had them do similar repairs. The data collected was very interesting. So with a technician A, 20-year experience, he's there doing his repairs, the conventional time, about 19 minutes. Same repair for a novice, less than 5 years, he's 34 minutes. And technician C, less than 5 years, 31 minutes. So the novices are pretty in line. And then we have another experienced technician who's a little faster than technician A. So it shows you that experience matters. I've trained multiple technicians and not everyone is created equal. I can say that very clearly. I trained a technician on a vehicle with a older vehicle that had a window motor that wouldn't go up in the right rear. So I was able to introduce him to the master switch at the driver's front, and how over time the wires in the accordion boot of the door would work harden and crack. So he was very much impressed that the problem was at the right rear, but the repair was at the left front. So by repairing those wires, everything's fine. A few weeks later, we had a new vehicle in with a similar right rear window not working. And I found him looking in the left front driver's door for broken wires. Now that would never happen in a brand new vehicle. So showing him the common failure on an older vehicle, he never understood why. So I took the opportunity to share with him what happens on new vehicles. A connector not fully seated in that right rear door is the more common of the failures. So those two examples gave that technician a more well-rounded, not just let me fix this vehicle today, but let me understand why the problem happened in the first place. The older vehicle and the work hardening of the wiring, and the newer vehicle with the not fully seated connector, both common failures for different reasons at different times that new technicians have to find over time and understand for themselves. The value of an intelligent diagnostic or remote diagnostic system is the ability to be a force multiplier. So in this case, the value that technician A and D had was years of experience, and through simulating that and walking a technician through, providing that similar guidance that I've done personally in the past, pulled all of those technicians to repair that vehicle in just about the same time. You know, it's 7 minutes and rounding to bring them all on the same level playing field. And you may wonder, why is this important? Well, with COVID-19, the expectation is I need things repaired, but I don't want someone coming to my house. Wearing a mask and me bringing a vehicle there, things have changed dramatically in our lifetime, and I don't see it ever going back to the way it was before. So having a remote diagnostic system where you can have a field force that's affordable for a company. You may not be able to staff 25 additional mobile repair trucks with seasoned veterans of repair technicians. That may not be cost effective. You may be able to put together a team of less experienced, so less expensive technicians, and support them with a remote diagnostic system. New products are easy. You can have a web-enabled connection on a new vehicle. The bigger challenge is, how do you manage the products that are already in the field today in a different way tomorrow than you did yesterday? And that's what COVID-19 has really required of the market. Those who change and adapt to the requirements of either the federal government, state, local municipalities are the ones that are going to survive. Here in North America, we had many workout and gym facilities not able to open at all. So that business owner had an option of putting their entire portfolio online or going out of business and waiting months until they could open again. So that flexibility to respond with your installed base in the field is what's so important. So the real question is, we know where everyone's at. Where do you want to go next in your diagnostic journey? I'm thinking the time is now for remote diagnostics. Here's a quick overview of the process. And I would point out that recreational vehicles and non-consumer electronics are really a focus, or should be a focus, for everyone today. And I'll close kind of with the customer expectations. So Amazon raised the bar for delivery. COVID-19 drove everyone in the service area to raise their bar on diagnostics. How are you going to handle those changes? Because if you don't, the reality is going to be you can be a Netflix or a Blockbuster. This is a regional reference, but in North America, Blockbuster went out of business here for the most part because they failed to see the future and adapt.